Hello everybody, welcome to the Soil Physics Lab of Lal Carbon Center at the Ohio State University. In this video, I will demonstrate how to measure saturated hydraulic conductivity, commonly referred to as KS, using the constant head method. This will be a live laboratory demonstration where I will show soil core preparation, saturation process, constant head setup, flow measurement, and calculation and interpretation of saturated hydraulic conductivity. Firstly, let me share with you the definition of saturated hydraulic conductivity. Saturated hydraulic conductivity represents the ability of soil to transmit water when all pores are filled with water. Kas, or saturated hydraulic conductivity, is important because it controls water infiltration, drainage, runoff generation, solute and nutrient transport. It's a key indicator of soil structure, pore continuity, and soil physical quality. Let's talk about the theory of water flow in soil. Water flow through saturated soil is governed by Darcy's law. According to Darcy's law, water flow depends on several things. Those are hydraulic gradients, cross-sectional area, soil permeability. Under saturated conditions, this permeability is expressed as saturated hydraulic conductivity, or Ks. There are several other methods, but we are using this constant head methods device for our experiment. But why we are using this constant head methods for our samples? This method is used when soils have moderate to high permeability. Water flow can be maintained at a steady rate. This method is commonly applied to sandy soil, loamy soil, well-structured agricultural soil. For very low permeability soils, a falling head method is preferred. Soil core preparation. Here we are using undisturbed soil core. These cores are collected carefully to preserve soil structure, trimmed flesh at both ends, wrapped and transported to the lab. Preserving natural pore continuity is essential for accurate saturated hydraulic conductivity measurement. The next step is saturation of soil core. Before measuring saturated hydraulic conductivity, soil core must be fully saturated. Saturation is done by placing core on a porous surface, allowing soil to rise slowly by capillary reaction from the bottom. This avoids air entrapment, which can significantly reduce measured conductivity. Then the next step is constant head setup. Here is the apparatus you can see. Now we will set up the constant head permeameter. This setup includes a water reservoir. Here is the water reservoir you can see. An inlet tubing supplying water to the soil core. These are the inlet tubing. A fixed water head maintained above the soil surface. The cores would be placed here. We could place 5 cores for this experiment per batch. And the outlet for collecting percolated water. The key requirement is to maintain a constant hydraulic head throughout the measurement. Now let's talk about how constant head works here. In the constant head method, a fixed water level creates a constant hydraulic gradient. Water flows through the soil at a steady rate. Once steady rate flow is achieved, discharge is measured. Steady flow indicates that Darcy's law conditions are satisfied here. Now let's talk about the achieving steady state flow. Initially, flow may fluctuate. We will wait until flow rate becomes constant over time. Successive volume measurements are similar, and thus we would understand that it's perfect to get the measurement now. Only after reaching the steady state status, we will take the measurement. And then measuring the flow rate. Now percolated water is collected in a graduated cylinder. Here you can see volume is measured over a known time interval. This gives us the discharge rate which is required for saturated hydraulic conductivity calculation. Constant head equation. There is an equation for the constant head measurement. Saturated hydraulic conductivity is calculated using the Darcy's law equation. Saturated hydraulic conductivity could be measured by different parameters: Q, volume of water per unit time; L, length of soil core; A, core cross-sectional area of the core; del H, hydraulic head difference; and T for time. This equation is derived directly from Darcy's law. Ka, or saturated hydraulic conductivity, is commonly reported in centimeter per second, centimeter per hour, or millimeter per hour. Consistent units are essential for comparison across treatments and studies. Now let's talk about the link among soil structure, pores, and saturated hydraulic conductivity. Saturated hydraulic conductivity is mainly controlled by macropore continuity, aggregate stability, biopore created by roots or earthworms. Well-aggregated soil generally show higher saturated hydraulic conductivity values. Interpretation of the results. For example, higher saturated hydraulic conductivity indicates rapid infiltration and drainage. Lower saturated hydraulic conductivity suggests compaction, pore blockage, or pore structure. However, extremely high saturated hydraulic conductivity may also increase leaching risk. Balanced saturated hydraulic conductivity is ideal for sustainable soil water management. Let's talk about some common sources of error. It could be incomplete saturation, air entrapment, unsaturated hydraulic head, disturbance of soil structure. Careful setup and patience are critical for reliable results. So this is how saturated hydraulic conductivity is measured using constant head method in a soil physics lab. Thank you so much for watching this video. Please like, share, and subscribe for more videos on soil physics, soil water movement, and soil health.